And the question says that some energy level for the hydrogen atom are shown. Okay, hydrogen atom. What is the wavelength emitted in transition X and wavelength emitted in transition Y? So, like if there is a transition from 3 to 1, there will be some release of photon, and from second to first there will be release of photon, that is X, and from third to first is Y, and we have to compare the wavelength of X divided by wavelength of Y. So first of all, we know that for hydrogen atom the energy is minus 13.6 upon n square. So for E3 we have minus 13.6 upon 9, and this is moving to N1, so E1 will be equals to minus 13.6. So the change in the energy will be E3 minus E1 will be minus 13.6 upon 9, minus of minus, so I'm directly writing 13.6, and if we have common 13.6, it will be now 8 by 9. So this will be the change in the energy. So this change in the energy will be equals to what? Hc by lambda here. So equals to Hc by lambda of what? Y. Y I have written. So lambda Y is equals to what? This will go in up and this will go in denominator. So Hc by 13.6 into 9 by 8. So this is the first equation that we need, and then we will do similar for X. So for X now E2 will be equals to minus 13.6 upon 4, because it is n square, 2 square is 4, and E1 will be minus 13.6. So change in the energy will be minus 13.6 upon 4, minus and minus of minus is plus, so 13.6. So when I will calculate them having common 13.6, it will become 3 by 4, and this will be equal to Hc by lambda, and lambda of what? X, because now we are talking about. So lambda x will go up, and that will come into the denominator. So Hc by 13.6, and this is 4 by 3. So I'll just rub all this. Now we have the both of the wavelengths, and now we require the wavelength of X divided by wavelength of Y. So wavelength of X is this, Hc by 13.6, 4 by 3, and for Y we have Hc by 13.6, 9 by 8. So this will be cut off 4 by 3 into 8 by 9. So this is 8 for the 32 and 9 3 27. So 32 by 27, C will be the right answer. So now we will see the mark scheme. Mark scheme C is right answer. So like this you have to solve the equation. First you have to calculate the energy on each of the orbits, each of the energy levels. Then you have to subtract them to get the energy of that photon that has been emitted due to the energy difference, and then you have to calculate the wavelengths, and then you have to compare it. So it's a very beautiful question. Just see the solution properly, and if you still have some doubt, just put it in the comment section. Thank you for watching this video.